Welcome back. Back in episode 198, I did a review of this Lux Pro headlamp, and we was actually out in the field at a campsite when I did the review, and I mentioned at some point in that video I would do a teardown of it so we could see just exactly how it operated. And well, this is that video. So just real quick, I'll run you guys through everything. There are two buttons at the top, and when you press this one, you get the main spotlight on bright, then it's on low, and then you have strobe and then off. I mentioned in the review video it would be nice if you could actually press and hold this to go through the modes, or press and hold to shut it off. You don't actually have to go through all 3 cycles, because the strobe light is kind of obnoxious, and I'd just rather not activate that if I didn't need to. And the other button over here is for the floodlights. The first one you get is white, then you get red, and then it goes to green. And the thing about that is you use the red for more of a night vision. And again, when I say night vision, it just means, you know, you have your natural low light vision, and then obviously if you turn on a bright light, you lose that vision. So you use the red to prevent that from happening. And a lot of hunters use the green to help identify blood. So if they, you know, shoot a deer or something in the wee hours, you can follow basically the blood trail, because the green highlights the red against the trail, and it just, you know, whatever. I don't really have a use for that myself. I can say though that the green tends to transmit a little bit better than the red does, at least for distance wise. And there's I'll put full specs in the description below on these different modes, so you can see what the lumens are and what the runtime is. But it's pretty good light. I used it quite a bit that night, both nights actually, and I liked it, you know. But there are some things about it I didn't like. Mentioned that, you know, the different modes, it goes high first, then low, then strobe. It'd be nice if it was programmable perhaps, or maybe you went low first, then high. Again, to help preserve night vision. You might not need the high beam, so maybe you want it to go into low, you know, whatever. The other thing is the floodlights. I'd prefer to go red first, then white, and then green, because green is the least I'm going to use. And I just want to be able to turn on red and not have my night vision disappear on me. That's one of the reasons why I converted this lantern in a previous video to red LED, so I have an actual red light source out there that's just red. I can say if you turn on one mode and then you hit the other button to turn on the other modes, it does shut that main light off. So that is one thing I kind of like in a way. This is replacing a clip light that went on my hat, and the clip light had one single red LED, although obviously a lot smaller of a reflector, and 2 red LEDs, and they were 3mm instead of 5mm. One good thing about this one is it runs on 3 batteries as opposed to 1, so the runtime is much greater. Obviously you get better brightness out of it too, but it does have that feature where you can shut off the lights with the button. The one out there, I would all the time think I'm shutting off the main light, let's say, and in reality I'm just activating the little floodlights. So, you know, you would go around with the main light on, and meanwhile you still have these little red LEDs on the side of it sucking up juice for no reason. So, you know, there's good and bad about both of them, and I know they all have their place. Again, that one's small, it just clips on the end of a brim of like a ball cap. And this one's obviously a much bigger unit that requires it to sit in your noggin. But this one you can put a hoodie over, you can do other things with, and not need a ball cap. So, you know, give and take. But anyway, that's not really the focus of this particular video. I figured I'd get that stuff out of the way at least. The focus is taking this guy apart. So we'll do just that right now. And this takes a 00 Phillips screwdriver to get these little screws out. So I'll go ahead, just buzz these out real quick. These are the ones that just like to disappear on you, so I'm going to use some care getting them out. Incidentally, if you don't have yourself a good screwdriver set, I strongly recommend getting one. I did the Scan Detect tool set review. I've also purchased this iFixit set. They're both really good pieces of kit. Oh, that's actually interesting. Okay, so this is all completely separate. I'll just let those reflectors fall out for now. That's just a plastic regular reflector, nothing special about those. And the glass is, it's not glass, it's plastic obviously, but it is separate, it looks like. I'm going to use care not to get my fingerprints in there. One of the other things in the review video I mentioned, this actually came with Alkaline Batteries. Lux Pro brand Alkaline Batteries. But Usually when you get these things, they come with some of those like crappy like carbon zinc batteries or stuff like that. So it's nice to see that they did come with alkaline. Looking inside, I mentioned this looked like a silicone seal. I was able to actually pick this out of place. It seemed like it tightened up a little bit more since I've used it. It's got this curious made in China sticker in here, which is interesting. It already has it engraved on the inside here, as you may or may not see. And again, oh yeah, I should mention this is the Lux Pro LP345. There was another model on the shelf that was the next one up, I guess you could say, and I opted for this one. The buttons in there seem like they're sealed in place, so that's a good thing. It might be pretty water resistant. I said it was rated IPX4, and it actually looks like they molded the actual plastic in there, because these studs in here are made of that clear plastic. So the enclosure is pretty decent. I could possibly see this little ridged area here wearing out. I mean, there are two of them, which is pretty nice. Yeah, all in all, it's not that bad. I can't tell if there's any magnification to that or not. It doesn't seem like there is. Yeah, that's pretty good. Let's take a look at this guy here. So this is actually soldered directly to the battery terminals, as we can see right here. So if I want to see the other side of the board, I'm going to have to do some disassembly. And I don't know if you can really pick it up on camera here. Perhaps we'll pull out the microscope later on, but there actually looks like there's 3 bonding wires going into this actual LED. So perhaps there's 3 individual segments to this one main chip. That's very possible. But looking at the rest of this here, there is that ambiguous chip. There is no code on that. I can't really tell what that chip is. We have the 2 buttons on the top, obviously. There's a diode over here. There is a very small resistor there. There's 2 small resistors here, and then 1 0-ohm link at the top there. And there's also a capacitor here, here, and a couple transistors. So now these are soft buttons. They're not like tactile switches, so they're not actually enabling anything. You're going to be switching on the actual computer itself. It does look like this chip is actually on a separate board, and then that board is soldered in from the back. And looking in on it from an angle here, it seems that that board is actually a piece of aluminum, I'm thinking, for heatsink capability, which is good because I know that can get hot. And it looks like what they did is they put a blob of solder over here, and then they just bent the tab over on top, possibly first to hold it in place. So I'll have to fire up the soldering iron to get that out. I should mark this. I do have a red and black Sharpie over here, a fine tip Sharpie. So we'll see, this is the positive side over here, so we'll have to mark this out. Put plus there like that. And I'll put the minus over here. Let's just double verify that. That's this side here, yep. That is indeed the negative. So we'll keep that marked so we don't reverse the polarity when we reassemble this, because you guys know I tend to reverse polarity on stuff sometimes. You can see which one obviously the white LED is because it has the actual phosphor on it, just like this one here. Now these are 5mm LEDs, but they're the straw hat style. You can see they're much shorter than the traditional LEDs, which have that big dome on top of it. And that's probably going to adjust the way the actual beam itself is. I know when I did that big lantern, I bought a big bag of those straw hat LEDs specifically because that's what that used. As a matter of fact, I got all the ones I took out of here. So you could see that's exactly the same LED there. And I think they provide more of a wider beam pattern perhaps. Just for ha-has, I'll show you. Here's a 3mm standard LED, and these are 5mm standard LEDs. And again, these are white. You can tell by that yellowish phosphor material in there. From what I understand, chemistry on the LEDs, these are actually blue LEDs, and that little phosphor on there glows to give you white. I believe that's the way they work. So yeah, let me go ahead, get that soldering iron fired up and see if we can get these guys popped off here, get a better look at this board. Well, what have I gotten myself into tonight? What a fun project this was. So as you can see, I actually desoldered the LED, And I'll tell you what, having a good soldering iron that can get the temperature pretty quickly is pivotal, because this is basically a heat sink. It's an aluminum plate. So as you're trying to heat this up to melt the solder, it's just not going to do anything if you have a cheap iron. You need something that's really going to sink that heat in great and heat that solder up so you can actually pull it away. And this little guy, this little solder sucker here, just didn't cut it. I had to pull out the big guns because there was quite a bit of a blob on that. And if you remember, this sat back here, and they actually soldered it in from the front, so they just blobbed that on. And it's a good thing I did that, because this helped with the traces a little bit. Now you can see them here through the board just a little bit. This is a double-sided board, and well, basically what they did is all the LEDs are connected in the back, and then these three connections here are actually vias that go through the front, and there's another one of those vias up on the top here, and this is for the positive to go through. And they actually, if we look at it this way, this is where the positive comes in, as I marked. That goes along up here, and all these LEDs on this side are connected, and then one of these traces goes across the board to the other side over here, and then all the negatives, the top pair here, are connected to one of these. It's the middle one, and then so on and so forth. And you know, looking at all these components here, there are quite a bit. But what I ended up doing is I took out the microscope here, and through the magic of video editing, I'm going to place the pictures that I took of the components into the video here. I actually drew this piece here just like that, and I made little arrows here to what I read. And like, for example, this very tiny resistor right here, right above my fingernail, there's actually two of them right there. One of them says 822, that's an 8.2 kilo ohm resistor. So there are two 822s, one 103. The 103 is 10K. There is one I don't have marked on here, and that one's this guy over here, 204 it says. I can actually read that one. That's 204. That one ended up, I have that here someplace. That one's a 200 kilo ohm resistor. The capacitors are unmarked. I don't know what value they are, so those are going to be ambiguous, just like the chip. There's nothing on that chip at all. We can't read it. There are 3 transistors right here. Now those are NPN transistors that had a number of J3Y on there, and they said that that's similar to the S8050. They're 0.5 amp 40 volt rated. There's another transistor over here that's actually a N-channel MOSFET that's rated at 2.5 amps 20 volts, and that's an A2SHB. There's a diode here which had S4 marked on it. That's actually a Schottky diode. This has a lower forward voltage than a standard diode, I believe is what the case is with that one. So like I said, the only thing we don't know the values of are the capacitors and the actual chip here. There is a 0 ohm resistor. They're just using it as a link, and then there's 2 switches. So I looked at this and I looked it over, and you know what? Big Clive came to mind with the pad, and I said, what would Clive do? Well, he'd take a picture of it. So I did exactly that. I took a picture of the board with my tablet and shot it over to my computer and printed it out. Now unfortunately I only have a black toner laser printer here, but I managed to blow everything up, and well, as you can see, I traced everything out, and I got the back side of the board too. Backside's easy. If you follow these traces down, it just goes to these vias as mentioned, and they're connected in such a way where the red one connects to the middle, white's on this end, green's on the other. So obviously we flipped this over to get the other side. Now initially I had the image flipped, but it was just easier doing it this way, honestly. So this is what we came up with for the board. And doing this reverse engineering allowed me to actually make a schematic for this particular unit, and I'll get to that in a minute. But if you want to trace this out, you can kind of get an idea. Now, there's one of these pins is going to operate each individual color, and the way they did it is, as I mentioned before, it's switching on the negative side. So if we follow out this pin, for example, it comes out, it goes through a resistor and then into the transistor. There's the base, the emitter, and the collector. And the collector is actually what goes to the negative side of the LED. And the other side here also goes to the ground. That would be the emitter. So the collector up to here, the emitter to ground. So you're basically just using that as a switch, essentially, is what you're doing. And the other thing up to here is, if you look at the buttons, the little capacitor here goes between the button and ground. You push the button basically, and if you don't have that capacitor, this might register as you pushing it a few times. So you need that capacitor there to help buffer that pushing, and each one of those has a capacitor on it. And I'm thinking they're different values because they are different sizes. I know I'm probably oversimplifying this. I'm not an electronics engineer. I like to tinker around with this stuff, so it was very fun trying to figure this all out. If you follow, basically all this is the same for all those LEDs. It's the 8.2 kilo ohm resistor for red and green, and then the 10K resistor is for white. Now if we follow the other side over here, they did the same thing on this large LED. It just needs a different value on the actual resistor. Like I said, in this case it was the 200K, but instead of using an NPN transistor, they're using an N-channel MOSFET. So instead of a base, emitter, and collector, you have a gate, drain, and source. So this side over here is the gate, this is the drain, and this is the source. Other than that, I mean, it's essentially the same circuit. And this is just a much higher rated LED. I'm thinking maybe a 3-watt LED. I'm not 100% sure. I tried to just power it up right now on my bench with some leads over here on its own, just to see if indeed that was the case, if we can actually, as mentioned, if there's actually 3 chips in this or not. We could tell by the bond wires. There's 3 sets of bond wires in there. Usually you only need 1. Now I'm not sure if they're using that for current rating or if there is indeed 3 segments into that one thing. I can't really get it on there to see. I started getting it about 3.5 volts, and I started getting around 150 milliamps, and the thing didn't conduct yet. So I was a little leery about actually blowing out my little LED light here, especially since I just got this thing. But really, I mean, there's not much more to it. That Schottky diode, if you follow, power comes into that and then just runs through. It's the same plane here, and that just goes up to this pin here. And it was kind of hard following this because some of the pins come through the outside here like this, but a couple of them actually go up and underneath, and they go under here and under that resistor up to here. And one of them goes to that capacitor, and one of them goes to that button. It seemed like, as far as I can remember. Yeah, oh yeah, and one of them had to go to this resistor here because there's only enough of them to come out. So looking at this, looking at that, looking at my hand-drawn thing with all my little notes on here, what was what, I came up with a schematic, and I started drawing this. I'm fairly good with drawing schematics, but the thing is everything was all over the place, so I just used some software, and that's it. Now I oversimplified this. The ground, you can see they're on their own little thing here. There's no ground plane. I just did the little symbol instead, and I did the same thing for power, 4.5 volts in, just because it was easier than trying to have to draw this all out and make it into, you know, a harder thing. I call this chip view because we're looking at that chip dead in the middle and everything branches off from it. So this is definitely not a proper schematic, I guess you could say, but if you guys want to take a look at that a little further, you can go ahead and pause this right now. But everything's marked on there. You can see the values of all the components other than, as mentioned, the chip and the 2 capacitors. This is a program called Express SCH, and it's a member of the Express PCB brand. You can go to expresspcb.com and actually download this free software. You can design your schematic, you can put all the component values in it, and then it builds a bill of materials. Then you can take that, you can go into the Express PCB program, and then you can actually build the PCB from your schematic, and it'll import over all the values and everything here, and it'll kind of like run through it to make sure it's a complete circuit, if you will. And then you can send that to the company and they'll make the PCBs for you. And it's actually a really intuitive program to use. The only unfortunate thing is you can't import this or export this to other programs as far as I know. So if you know, like EagleCAD, for example, you'd have to redo it in the EagleCAD. You know, you don't have a way of doing that. But really, I mean, pretty interesting way to go about actually trying to reverse engineer something. I tell you, the scope around focus microscope, this is a Wi-Fi microscope that I've reviewed in the past. This thing was awesome. I was able to get this up underneath it, and I got really close to it, and I actually had no problem going through that and actually getting some high quality images. And I also used this live with my tablet to just go ahead and trace out as much as I could. And then afterwards, I can possibly show you guys this. I figured out I could have just held it up to the light. That would have made it a lot easier. I'll try to do this on camera. I did it with a lower powered light before, but if you do this, you can actually see, hopefully the camera doesn't swamp it out too much. You can actually see right through the board. Yeah, I think this might show pretty well. There you go. I won't get any closer because we already have a schematic of it, but you can see all the traces on there pretty nicely. And the other thing I had to do with this was I actually had to clean the board with some rubbing alcohol to get the old flux off of it from when they manufactured it, because it was a hard, really, especially on the microscope, it was hard trying to see all the traces because they were just getting obscured by the glare from the actual stuff on there, the flux. Anyway guys, that's really going to wrap it up for this particular video. I'm going to go ahead and put this thing together, get this video edited so you guys can have something to watch this Thursday. Anyway guys, catch you later.